What is up, everyone? Welcome to episode 3 of my Home Lab Angel Server series. I'm working on turning a used Dell Optiplex into a real impressive home lab server setup, something like this maybe. No, probably not like that anytime soon. But in the last episode, I just worked on managing my local services through deploying Docker and Portainer. But in this episode, I'm going to be exposing my server to the internet, making a publicly accessible Minecraft server, and setting up Tailscale so that I can remotely manage my server from anywhere in the world. So this should be pretty fun. Oh, my door's opening. I think my cat is probably coming in. Hold on. Oh, it's the orange one. I almost forgot the hat, y'all. You know I can't forget the hat. So obviously the first thing we're going to do is just jump into the terminal here, and I'm going to SSH into my server. So the very first thing I'm going to do now that we're in here is I'm going to run a make directory command for all of my Nginx Proxy Manager data to live inside of. So like I mentioned in the last episode, this volume is persistent. So if I ever have a problem with Nginx Proxy Manager, I can just delete the container, reinstall it, and all of my SSL certificates and everything will be safe inside here. And now I'm just going to go ahead and use Nano to create a compose file, which are just the basic instructions for Docker on what to do with this Nginx Proxy Manager container. So in this compose file, I've just got the image that Docker is going to need to pull the container from. I've got the ports, and as you can see down there, I've got the volumes, which are mapped to those data directories that we just created. Now that I went ahead and wrote the compose file, I'm just going to do this docker compose-f, which is going to direct it right to that compose file that I just wrote. And then I'm going to do up-d, which just means detached. So this container is just going to keep running in the background. And perfect, as you can see here, it's now up and running and ready to go. Now my service is up and running, but it's not going to be working just quite yet because I'm going to have to allow some certain ports through my UFW firewall on Ubuntu server. I'm going to start with 443. This is just the standard port for encrypted HTTPS traffic, I believe. This is going to allow people outside of my network to direct traffic towards NPM, which is going to direct it towards different services on my server. And now I'm also going to allow port 81 through. This one isn't for public access. This is just so I can access the web dashboard and manage NPM right here in my web browser. Now that I've set up the firewall rules, I think it's the perfect time to explain why I'm even using Nginx Proxy Manager to begin with. And it's because I tried to set up port forwarding on my router through Cox, specifically port 80, and it turns out they don't allow you to do that because it's commonly used for attacks. So I went the route of having Nginx Proxy Manager, which all incoming traffic is directed to Nginx Proxy Manager through port 443, and then it does all the work of directing that traffic to the different services running on my server. Now, in order to get an SSL certificate, typically I would have to have port 80 open so that the internet can see and prove that I own my angelserver.live domain. But since I'm not able to set up port forwarding for port 80, I'm going the route of doing a DNS challenge on Cloudflare. I'm going to set it to zone, DNS, edit, permissions, and I'm going to get the token from Cloudflare, paste that into the NPM new certificate, and NPM is going to go ahead and request a new SSL certificate from Let's Encrypt. So I just opened up that new NPM dashboard on my web browser here. In domain names at the top, you can see I put star.angelserverlive. Now this is actually a wildcard domain, so you can see the dot before angelserver.live. That actually reserves any subdomains. So if I want to do mc.angelserver.live for my Minecraft server, I can do that, or any other, versions of angelserver.live. This certificate will reserve all of those for me in the future. And then of course, just the domain name after that as well. I went and selected Cloudflare as my DNS provider and pasted in that token from the DNS challenge right there. Now, just like I did for my other services, I'm going to go ahead and make a directory for my Minecraft server that I'm going to be deploying next. This is where all of the world data, maps, what else? Player progress, server settings, everything is going to live inside this directory, and it's going to be persistent just like the other volumes that we created, so that if I need to ever restart the Minecraft container, all of my world data is going to be just fine. So I just did change directory here into that new Minecraft directory, and we're going to have to create a Docker Compose file, just like we did for our other service, npm, previously. Now, if you take a look inside my Compose file here, you'll see some similarities to the one I wrote earlier. I've got the image file there. That's, of course, Minecraft Bedrock server. We've got the container name. I'm naming it just Minecraft Bedrock. I'm going to be setting the game mode to survival, difficulty to normal, server name, pretty basic. Now the ports, you'll see there, 19132. That is the port that Minecraft uses. So when people send traffic to my router forwards it to 19132 on my Ubuntu server VM. The Minecraft container receives the connection through the UDP protocol. Now, I know from my Cisco classes that UDP is different than TCP. TCP is typically used for web traffic because if a packet is lost, it will retransmit it. In UDP, it's for speed for things like gaming on a Minecraft server. So it's connectionless, and there's not that, back and forth. Did you get this packet? Did you get that packet? It just continues transmitting data. Now again, of course, I have to do docker compose -f, direct it towards that compose file I just wrote, and then do up-d. Same thing as the last one. It's going to be detached, so this container is going to continue to run in the background of my server. Now, I can't be 100% sure that the server is actually up and running just because I did the docker compose up-d command. So here I just went to check the logs by doing docker logs -f Minecraft Bedrock. And in the logs, I found this beautiful server started message, meaning that everything should be good to go. But of course, it's never that easy. I tried to open up the server on my Minecraft Windows 10 edition here, and I got this multiplayer connection failed error, and I wasn't immediately sure what the problem was, but after I went back and looked at my DNS record on Cloudflare, I realized that, as you can see here, my A record was set to proxied instead of DNS only. Now, you actually cannot proxy UDP game traffic through Cloudflare. It has to be set to DNS only in order for the server to actually work. So I went ahead and flipped it back over to DNS only, and I'm going to try to load back into the server now. And yay, this is a good moment of celebration because now, as you can see, I loaded into the Minecraft server just fine. I can play, I can access it from outside my home network, and everything is up and running and ready for my friends to join. Now my server is publicly accessible through the Minecraft server container, but it's still missing one big thing that I really need. What is it? Well, I want to be able to manually configure my terminal, my server, check my logs on my Minecraft server from anywhere outside of my house. So to do this, I'm running this curl tailscale command on my server so that I can get Tailscale up and running. One quick authentication later, and this server is now a part of my private Tailnet. I've added my MacBook and my phone onto the same Tailscale account, so theoretically all of my devices should be able to join a mesh VPN where I can have access to my home server no matter where I am in the world. So let's see if this holds up to be true. I'm heading out to the wild. No more local IPs, no more home Wi-Fi, no more 100-foot Ethernet cord runs. Let's see if I can manage the Angel server from anywhere in the world. I figured, what better way to test my Tailscale remote connection than to bring my entire setup to the local park. I got a studio mic, I got the noise canceling headphones, keyboard, mouse, everything out here, and we're gonna try it out, make sure it works. So I'm touching some grass, enjoying the nice day. It feels pretty good out, a little cool. Maybe I should have brought like a coat or something, but yeah, let's get started. So now anything and everything I can do on my home network, I can do literally anywhere. I'm just connected to my mobile hotspot. I will say that it's pretty fast out here. I've got Tailscale up and running, and now I can go into my Portainer dashboard here. I can go into the command line in SSHN. I can go to Proxmox. I can do literally anything that I could do at home from out here. Now the question is what? I mean, I thought this would be funny to just bring my laptop out here, but now I'm like, okay, now what do I even do? Because it's more just to show you, like, I can actually do it. You know what I'm saying? Anywhere from anywhere in the world. Now you might be wondering, why do I need 16 gigs of RAM to run a Minecraft server? Well, the answer is I don't. But you know what I do need 16 gigs of RAM for? Pulling up this B-top dashboard at my local park. Isn't this cool? I mean, look at that. We're only using 1% of our CPU. This is just truly amazing, guys. What else can I do out here? I can run NeoFetch and see my server uptime. Amazing. Now you might think this setup is a little too much. You might wonder why you would even want to do this. Couldn't you just do this from your house? But of course you could do this from your house. That's just not the point. You know what I'm saying? The point is that whenever I get the urge to work on my Ubuntu server, I can, no matter where I am, and that's what we've set up today.